Hello students, I hope you will be fine. Stay home, stay safe. Today is our second lecture of chapter number 2, kinematics. Today is our topic scalars and vectors. In physics we come across different quantities such as mass, length, time, temperature, density, volume, speed, etc. So we divide these quantities into two categories called scalars and vectors. Scalars are those quantities which are completely described by its magnitude only. By magnitude we mean a number with a proper unit. For example, we have a quantity mass, so it has a magnitude 2.5 kg. Similarly, for time we mean 40 seconds, and such as a distance or length 1.8 meter. The examples of scalars are mass, length, time, speed, volume, work, energy, etc. Scalars will have only magnitude, they don't need direction, and they obey ordinary algebra for addition, subtraction, multiplication, etc. For example, if we add 2 seconds with the 5 seconds, so they become 7 seconds. So scalars can be added, subtracted, or multiplied just as ordinary numbers. On the other hand, vectors are those quantities which are completely described by magnitude as well as directions. The examples of vectors are velocity, displacement, force, momentum, torque, etc. So if we describe a quantity without direction, it will be meaningless. For example, the distance of a place from a reference point is sufficient to locate that place. The direction of that place from reference point is necessary to locate it. For example, look at these figures. Here two forces are acting on the table which are in the same direction. On the other hand, in the second figure, the two forces are acting in opposite direction. So does they produce the same effect on the table? No, obviously not, because they are different in direction. Similarly, when we say we are walking at the rate of 3 km per hour towards north, then we are talking about torque. Then we are talking about vector. Vector quantities requires magnitude as well as direction for complete description. They have their own algebra for addition, subtraction, multiplication. This means that we cannot add or subtract or multiply the vectors just like scalars or other numbers. They are represented symbolically as well as graphically. Representation of vectors. Vectors can be represented by two ways. One is symbolical, the other one is graphical. Symbolically, the vectors are represented by letters with boldface or with an arrow above or below them, just as shown here. For example, force, acceleration, and displacements, they can be represented symbolically with bold faces or with arrows above or below them. Graphically, the vectors are represented by arrows whose length is proportional to the magnitude of the quantity. The direction of the arrow is taken along the direction of the vector quantity. Here in this example, a vector quantity v is represented by a long arrow. Here the length of this arrow represents the magnitude of this vector v, and the arrowhead represents the direction of the vector v. As an example, represent a force of 80 Newton acting toward north of east. So let's solve it. In the first step, draw two perpendicular lines to each other. The horizontal line represents east-west and the vertical line represents north-south direction as shown in the figure. In the second step, choose a suitable scale to represent the given vector. In this scale, let 20 Newton becomes equal to 1 centimeter, so 80 Newton will become 4 centimeter. In the third step, according to the scale in the direction of the vector, in this case, draw a line OA of length 4 centimeter along north-east. As an example, here we have taken the coordinate system north, east, west, south. So we draw an arrow which represents the vector which starts from the origin. So by putting an arrow head and the end of the line, in this case the arrow head is at point A. Thus the line OA represents a vector, that is the force of 80 Newton acting towards